Hey guys, welcome back to AEC-VC. So this week I have a banger analysis for you, an analysis that has never been attempted or done before and which is footed on some of the best scientific research when it comes to the energy consumption of AI generation. And I apply that analysis to the 3D generation of BIM or CAD within the architectural and construction space. It's a banger analysis. Stay tuned for the next 10 minutes and I promise you the number 875, it will stick with you. Hey guys, as you know, we with Fundamental have invested in a bunch of 3D CAD, both for AEC as well as for manufacturing over the years. And we have gained a particular taste and appreciation for the complexities that 3D presents in designing and recreating our real world. You can't recreate the real world without putting a lot of it into 3D and authoring in 3D, manipulating in 3D and sharing in 3D. And now with the advent of AI for especially the last 2 years, we've been pitched a lot about AI generated 3D models, AI generated support of authoring, etc. So that in itself is very exciting because it sits at an intersection of things that excite folks from the 3D side and from the AI side. But there's one particular aspect that I wanted to understand. And so I spent a lot of time these past few weeks understanding the energy cost of the AI generation of 3D modeling for the real world, for CAD in architecture, engineering, and construction specifically. So this is not about gaming, this is about the real world, BIM and CAD. And so let me start with giving you some everyday benchmarks first. So if you spend 1 hour Netflix streaming, you're going to consume about 0.8 kilowatt hours of energy. Laptop gaming 0.5, laundry about 4.6 kilowatt hours of energy. Just to give you a general set of everyday kind of benchmarks. Air conditioning is not as bad as your laundry. As you can see, everything here will depend a little bit on the efficiency of your technical equipment, of course. So these are more like general and directional benchmarks, but they give you an idea. So I studied a lot of the scientific results that were published the last 1.5 years of the energy impact of AI generating in and around the 3D models. And I want to kick you off just with not the 3D side, but the semantic side with large language models. And so one particular study was extremely well researched. And what you can see is that from text classification to even captioning images, so reading an image and generating text for it, you're in and around 0.002 kilowatt hours to 0.063 kilowatt hours. The one thing that stands out is the image generation. So image generation, you're at almost 3 kilowatt hours for one image. You know how much that is? That is more than baking for 1 hour in your oven, just to give you a perspective here. And so image is obviously generated not even as a vector in these programs. It is generated as a non-editable JPEG, and it is by far very, very far away from the actual complexity of a 3D model, 3 kilowatt hours. And so this number caught my attention and made me want to think and learn and study more about, okay, what would be the energy impact actually for 3D generation? And so more study results were published. This study that you see here is from 3D scanning with medical devices. So we have to translate here from the voxels that get scanned in this study to a polygon-based approach. That was the easiest way to bridge for me. So don't add me about B-reps, etc. I get all that, but I had to transfer it into polygons, etc. in order to make the kilowatt hours in a 3D modeling environment somewhat comparable. And it worked quite well, as you can see. And so in the end, what you came up with in sort of a range is that if you want to do a 3D polygon-based modeling, you will end up with somewhat these ranges. I understand they don't mean anything to you right now, but I just want to also put you through the process that I put myself through. And so with that, I then calculated what the energy consumption in 3D BIM CAD authoring would be based on AI. And what you can see here is I took 4 different reference projects. I took a regular 150 square meter 2-story residential single family home. I took a 6 apartment multifamily home. I took a 10,000 square meters office building, roughly that's roughly 110,000 of square feet, and an international airport. So these are 3 reference projects that I put through. And as you can see, obviously the energy consumption does scale with the complexity and the number of, let's say in this approach, polygons that would have to be created. And an international airport would go anywhere from 100,000 to 1.7 million kilowatt hours, most likely in and around the 700 to 1.2 million kilowatt hours. I'll reference that back later, whereas a single family home is much, much lower. 10,000 square meter office building would be in and around the 150 to 200,000 kilowatt hours for one single full iteration of a 3D AI generated model. So this is not about the manipulation. This is not about creating multiple versions. This is one single full version, fully AI generated. Now, if you look at that from an energy cost perspective, I used US dollar wholesale energy prices here. So this is not even Europe, which has more expensive energy prices. This is not retail prices. This is wholesale energy prices. And you can see that based on to AI generate one full iteration / version of some of these projects, this is the energy cost that you would have to pay. For an international airport, it would be anywhere between 80,000 to 220,000. For a single family home, it would be in the couple thousand range. And then this office building would be anywhere between 20 to 40,000, right? So if you only need one version, if that's all you need, from an energy cost perspective, this might actually be much cheaper than your human labor. I'll come back to that though. But put that into context of the everyday benchmarks that I showed you. So in order to generate just one version, one iteration, this is similar in the international airport to 185,000 hours of laundry. It's equivalent in the airport to 21.5 million hours of running a 40-watt halogen light bulb. In the case of even a single family home, it would be 2,500 hours of doing laundry or 6,500 hours of air conditioning. Just to put it into context, to get one iteration of said project running your air conditioning for 6,500 hours is possible. So that gives you a little bit of an everyday idea of what AI generation in 3D for architecture would actually mean. Now I'm going to really blow your mind, because once you put this into a different perspective, a really interesting insight arises. So now let's compare with the human modeler. So I've only had to make 2 assumptions here for this specific comparison, and that is a human modeler that is trained in Revit in 1 hour can model 1,000 polygons. Again, I have to stay in the polygon world here, and will need 83 kilocalories per hour, which is about the 2,000 kilocalories per day that an average human in and around might need. With that, the human would take about 10,000 hours to model the international airport, or 140 hours to model the single family home from scratch, right? So again, this is one full version from scratch to compare it with the AI generation of it, which means the human would need 13 kilowatt hours or 1,000 kilowatt hours to generate the same models. 13 kilowatt hours compared to what you have here, or 1,000 kilowatt hours compared to the international airport, which runs between 500,000 to 1.2 million kilowatt hours. So that gives you a very interesting perspective. And that would be equivalent to, in the case of a human modeler, 7 hours of air conditioning for the single family home, or 540 hours of air conditioning in the case of the airport, 200 hours of laundry in the case of the airport. This means that the human brain and the human body is about 875 times more energy efficient in 3D modeling than AI. Let that sink in. 875 times more energy efficient than AI in creating one version of a 3D BIM CAD model for any of these asset classes than AI. That is almost 3 orders of magnitude. In terms of the cost comparison though, the AI will shine under certain conditions. So you see here that to create one version, the AI will need about 2.3 times less cost if you only factor in the energy cost versus a salary. I used a salary for a human architect in a New York City practice. If you actually don't even make that assumption, if you use way cheaper labor, the cost will actually tilt in favor of the human a little bit more here. So I try to use a New York City based salary. So the energy cost will be 2.3 times cheaper for one AI generated version than one human generated version. But the big question is this: how many iterations of the same model will you actually need to nail your model, assuming that either AI can do it alone or, of course, the human can do it alone. And that is the 2.3 full iterations. If you need more than 2.3 full iterations, the human modelers will be less expensive than the AI, which means that the AI not only is completely wasteful in energy, it will most likely also be completely wasteful in cost compared to the labor side. So most likely I understand that the future of AI-enabled 3D design workflows in architecture will either be that the AI generates a first robust version of the model, and then the human will do the finishing of that model, or we use AI to perhaps iterate on very specific parts of the model and let humans generate other parts. So there will be a combination and collaboration between AI and human. But still, this like-for-like comparison shows you just how wasteful AI will be for 3D generation in principle. My conclusion from that is it's very obvious that AI-generated 3D architectural models will be most cost efficient, but far less energy efficient for regular run-of-the-mill type residential or small commercial projects. Why? Because details either matter less or because they are hyper repeatable. If you try to generate AI for very detailed models, you are quickly in a very wasteful state of doing these things. For highly complex, highly detailed projects, it just doesn't seem obvious to me, on both cost as well as energy, even more so on energy, that AI generation can actually create a substantial advantage in the modeling process beyond the very, very early feasibility and low LOD designing. This is very important insight, guys. So everybody who is a fan person of AI generation for 3D, you need to understand this analysis and you need to understand the conclusions that I'm drawing here. Humans might just remain more efficient for most parts, and the efficiency, I have a number for it. It's 875 times more efficient. Thanks, guys, for listening. Hey, guys, thanks for tuning in. Make sure that you subscribe under acvc.com, and you can also find me on LinkedIn. See you next time.